Okay, your lesson today is going to use the Pythagorean theorem that you learned about yesterday, but what we're going to be able to do, since it is an equation, we're going to be able to solve for the hypotenuse that is going to form between the two legs of the triangle. So the steps that you need to fill in first for your notes, we're always going to show our work by writing the formula. Remember, that's a squared plus b squared equals c squared, or you could use leg squared plus leg squared equals hypotenuse squared. The next step to use any formula is to substitute the values that you have. The problems that we're going to do today are going to give you both legs of the right triangle, which is the a and the b value in the formula. To simplify the formula, similar to what we did yesterday, you will square both of those values first. So you'll do the actual squaring of a and the squaring of b. Then you're going to add them together, again, similar to what we did yesterday. The difference is at the very end, you need to solve for x, the missing quantity, which is going to be our hypotenuse today. So to do that, you will need to take the square root of both sides. And as you know, sometimes square roots do not come out exact, so you will have to round your answer. And typically you're going to round to the nearest tenth. So what we have here is our first example. As you can see, we do have a right triangle. One of our legs is 5. One of our legs is 12. So it's a good idea to label what you've been given and label what you have missing. We're going to use x to represent this hypotenuse. Hypotenuse, remember, is always the longest side connecting the two legs. It's also always across from the right angle. So if we have to find this measurement and it's unknown, we could use the variable x. We can start with our Pythagorean theorem formula that we learned about yesterday, a squared plus b squared equals c squared. Remember that your legs are always your a and your b values. So we're going to put one of our legs in as 5 and the other leg in as 12. Since we do not know our hypotenuse today, we're going to use the variable x. X is also going to be squared because the formula for Pythagorean theorem, remember, takes the area of each leg's square and it equals it to the hypotenuse's square. So anytime you're solving an equation, you want x by itself. And in this case, x is over there, but it's squared, and we're going to deal with that later. On this side, we're going to do some simplifying. And like I said from yesterday, you're going to square both of your legs. So 5 squared, remember, is 25. 12 squared is 144. And then you're going to add those numbers together. So we still have an equation. We could draw our locker down here to keep it organized if we want to. But we're at the point where we're ready to take the square root of both sides. Remember, square rooting is a way that we use to undo squaring. This exponent here we need to get rid of. So to get rid of squaring, we said we're going to do square rooting. Square rooting is the inverse of squaring. So this will give us the value of x. And if you recall on your calculator, in order to do a square root, you would have to use two buttons. You would have to hit second, and you'd have to hit x squared. You want that to look like that on your screen. And then again, you would type in the number that you're trying to square root. This does come out exactly 13, so we do not need to round. The hypotenuse of this triangle is 13 centimeters. Again, we know that because it's a right triangle, and every right triangle you can take a squared plus b squared to figure out what c squared is, or in our case we found out what this hypotenuse is. It's 13 centimeters. So again, make sure you have your formula. You substitute it into your formula, you've simplified, and then that very last step is to use what we know about square roots to undo the squaring. We can cancel these out to show that we now have x. And again, the square root of 169 is 13. Future examples will do some rounding, but for this first one, I wanted you to see that it can come out to be exact. Your other notes page should have a little right angle in this corner. All right, it should be a right triangle, and that's how we know we can use our Pythagorean theorem. We have one leg on this side, one leg on this side, and we have our hypotenuse missing again. So we will start by writing our formula, and we will plug in the values of our legs. Our legs are 3.6 and 8.2. We have a hypotenuse that is missing, so we will use the variable x. Again, to solve, we're going to square both of our values. So I believe 3.6 squared is 12.96. 8.2 squared is 67.24. And adding those together should give us 80.2. At this point, we are not finished. 80.2 is equal to x squared. Remember, we want to find the value of just x. So remembering that at the end of these kinds of equations, you need to get rid of this exponent of 2. Remember, the opposite is 2 square root. So again, with your calculator, you're going to hit those 2 buttons to get your square root symbol on there. You're going to put in your value. And this time, as you can see, we're going to get a decimal answer. Your decimal answer will typically get rounded, and I believe we'll go with the same directions as the last problem, round to the nearest tenth. So our x value is approximately, well, it'll go up to 9.0. If you remember the rounding rules, if you want to round to the nearest tenth, you're going to look next door. 5 or higher bumps this up. The only way to bump up a 0.9 is to bump up the next value to the left. So in this case, we're going to have approximately 9 centimeters for our hypotenuse. So make sure you're labeling. Make sure you're identifying that, yes, we rounded this answer off. The next example did not give us a diagram. So what you're going to want to do is you're going to want to draw one. And again, it doesn't have to be perfect. It's just a sketch. The sides of the triangle, it should say the legs of the triangle measure 10 and 12. And since we're finding the hypotenuse, that's where your variable x is going to go in your diagram. So again, we know it's a right triangle, so we can use Pythagorean theorem. We have our legs of 10 and 12, and we're looking for our hypotenuse. We can take our values and simplify because we know 10 squared is 100, we know 12 squared is 144, and this will add up to 244. To finish solving, remember there's no way this can be connected by 244, so we need to remember our last step is getting rid of the squaring. We're taking the square root of both sides. The square root of 244 is 15.62049935. Our directions are very specific in this one. We round to the nearest tenth, so this time it's 15.6, and the units were feet. Make sure you're showing your work. I know there isn't a lot of space here, so if you need to write it on your notebook paper and then just tape this on top of it, that's fine. The last example is a word problem. It says Anna is building a rectangular picture frame. So we always want to draw a diagram to show what's going on. The sides of the frame are 20 by 30, so we'll make this 20, we'll make this 30. What should be the diagonal measure? So the reason we know this comes out to be a Pythagorean theorem question is rectangles have right angles in the corner. If you draw a diagonal from corner to corner, you're basically forming the hypotenuse. So this is what we're missing. We want to find the length of that diagonal. We're going to round it to the nearest tenth. We already drew our picture, and it says specifically use Pythagorean theorem. So a squared plus b squared equals c squared. Your legs are the 20 and the 30. So always remember, put your shortest sides there. We're missing our hypotenuse. So simplifying, we have 20 squared, we have 30 squared, and we're going to combine them together so that we can solve. 1300 is x squared, so remember to solve for an x squared problem, we use the opposite and we square root. Square root of 1300 is 36.05551275, and it said round to the nearest tenth, so we're going to say it's about 36.1, and these are inches.